We have Andrew Spaeth and Matt Reilly who are presenting this evening. I'm really excited to hear from these guys. Andrew is our Hood River and Wasco County Forest Collaborative coordinator. He's also, and I didn't know this until tonight, somehow I missed this, but Andrew has a master's in public policy from Oregon State University, but he hung out with all the cool kids in the College of Forestry. So I always thought he came out of the College of Forestry, but so he's got a lot of forest management knowledge. And then Matt Reilly is at Oregon State University College of Forestry now. Before, not too long ago, he was with the Pacific Northwest Research Station, with the Forest Service's Pacific Northwest Research Station. And you were one of the authors of the climate vulnerability assessment, is that right? Yeah. Yes, okay. So he did, at one point, at some point, I heard that you give a talk, and I'm pretty sure it was to us, but it could have also been the Forest Collaborative. Everything kind of blends together. But anyway, these guys are really well poised to talk about, you know, sort of climate impacts to our forests, our local forests. You know, they're going to be talking about the unique aspects of where we are in terms of forest vulnerability, and they have a full, definitely a full presentation, so with good detail. And so I'm not going to talk anymore. I'm going to turn it over to them. Who's first?
Andrew's
All right.
okay. It's a pleasure to be with you all. Thanks so much for taking time out of this beautiful evening to be here. As Cindy said, my name is Andrew Spaeth. I facilitate the Hood River Forest Collaborative. I'm going to start by sharing just a little bit of background and context about the collaborative, who we are, and some of the programs that we lead. I'll hand it over to Matt to kind of dig into the science and the research that he's been leading and collaborating on this topic. And then near the end here, he'll hand the mic back over to me to wrap up with some more local context. The mission of the Hood River Forest Collaborative is really about advancing triple bottom line solutions to the challenges we face regarding forest ecosystem health, wildfire risk, and rural economic development in the county. We have 18 steering committee members and operate on consensus. Our process of building consensus is rooted certainly in an understanding of the science, but also in law, regulation, and policy as it relates to public lands, social values that people have, and cultural uses of the forest, and operational realities and the economics of what it takes to do restoration. I'm going to highlight just a couple examples of partners that we're working with and things that we're really excited about right now. One of our partners is Smoke Ready Gorge. This is an initiative led by Oregon State University Extension. They're focused on increasing the amount of air quality monitoring that we're doing here in the community, especially at schools and in other locations. And as we experience more wildfires and have more smoke events in the summer, this is a really helpful way to better understand what air quality is in the gorge. And also they're conducting a lot of education and outreach to try to help the most vulnerable members of our community be better prepared for future smoke events. We're really excited. In the last couple of years, we've expanded the scope of our work to be more inclusive of wildlife enhancement projects. And we've been working over the last few seasons at Gibson Prairie. There's a historic meadow complex that we're working with the Forest Service to restore. And there's also a couple of old grazing allotments that we're in the process of pulling all the old barbed wire out of the prairies. And so this is one of the work parties that we had last fall doing that work. I'd be remiss if I didn't mention our partnership with the Hood River Watershed Group and our volunteer of the year this last year, Dave Bookman, who's with us in the audience. Dave has done a phenomenal job in really trying to help us better assess the condition of our forest roads, analyze where we're seeing the potential for sedimentation to enter streams from the forest road system, and give better data so we can prioritize investments and strategies to try to restore forest roads and reduce impacts of roads. The last program area I'll mention before we transition to Dr. Reilly's, in addition to kind of the work we do with the Forest Service that's focused on restoring forest health, more broadly on the landscape, we've been working in partnership with the Soil Water Conservation District to start a free mobile chipping program that they've since really adopted and run with. They've served more than 100 landowners and homeowners in the community who are implementing defensible space practices, providing a great free service to the community. We're doing a lot of education and outreach events. We've done events in the Upper Valley as well as Spanish language events in Hood River. And then finally, we're partnering with Oregon Department of Forestry, the local fire districts, and others to create basically the opportunity for homeowners to receive free home assessments and get recommendations from local fire districts about actions that you could take to reduce the potential for structure loss during future fires. Before I hand it over to Matt, when I was talking to Cindy about this presentation, I think a couple of the concepts that I'm sure you're familiar with, but I want you to keep in the front of your mind as we're talking through this, the impacts of climate change on the Hood River Watershed tonight, are mitigation and adaptation. So forests obviously play a critical role in sequestering and storing carbon that can mitigate the effects of climate change. If we can create the conditions for trees to survive climate change, we can ideally, limit the effects of climate change here and hopefully globally if we all collectively do that. At the same time, and what you're going to hear from Matt is that there's pretty much no future in which it doesn't get hotter and drier here. And so we also need to be thinking about the actions that we can take to adapt both our communities and our forests to be better prepared for the inevitable future that is going to be include more likelihood of drought and more likelihood of fire. So keep those things in mind, and as Matt's talking, be thinking about the strategies that we might deploy that are mitigation and where we need to focus our adaptation work. Matt? Sure.
Thanks very much, Andrew and Cindy. And let's see, today I'm primarily going to focus on fire as a mechanism of forest and vegetation change. Certainly there's things like insects and drought where the processes are a little bit slower, but fire is it's a really visible factor on the landscape. It's very visceral when you see these large patches of high severity fire. And things can change very, very quickly, right? And I know, here on the east side and even on the west side, I think everyone is now familiar with fire as part of our natural disturbance regime, right? And I have here just a figure. I'm going to show you all lots of figures today. Looking at area burned in the western US that primarily is the 20th century there, from the early 1900s till about 2000. And what you can see is a very, very active period of fire there in the early 1900s associated with colonization and settlement, things like that, early logging. And then this fire-free period where we just didn't really have a lot of fire. And it's really interesting. This also corresponds with a relatively cool and wet period, specifically here in the Pacific Northwest. A couple other interesting things happen about in the 1950s too, is there's all this technology, airplanes and things like that come out of World War II that they start using for fighting fires, and they're very successful, right, for quite a while until about the mid-1980s. And so these days, despite all the money we put into fighting fires and things like that, we are not having the same successes in terms of excluding fire from these systems and controlling it as a natural disturbance. And it seems like everything I do by the time I reach a crowd like y'all is outdated. This slide here is way outdated. That millions of hectares up there is up about 5 or 6, I think, within the last couple years, maybe even past that. Yeah, it's tough to keep up. And so the other things we had during the 20th century was was climate warming, and this is just a figure showing seasonal changes in climate over the last 100 years. We can see that things have warmed across all seasons. We have decreased summer precipitation. And one of the big things that we get in the summertime, particularly that's pertinent to fires, is increased climatic water deficit, which is really sort of the difference in the amount of water that's available for a plant to use, and that sort of gets transpired and evaporated away. So it's a very pertinent metric for what's out there in terms of drought. We can also see that across Oregon and Washington, climatic water deficit is very strongly related to area burned. This is patterns of area burned and burn severity across Oregon and Washington for the last 25 or 30 years. Pretty slow there in the beginning, but certainly in the last 5 years, it's really ramped up with a couple of really large big fire years. It's related to increased fuel aridity, so fuels are drying out more in the summer. Up at higher elevations, it's related to loss of snowpack. There's also interactions with other stressors, right? So trees are dying from insects and changing the fuel structure, the amount of fuel that's available to burn. And then finally, we've also had the shift towards some of these really large wind-driven fires. Certainly here, the 2020 fires on the west side are an example of that. But we've had other examples of that in California, across the Western United States. So this is just a summary. These are some more recent results looking at basically fires they're increasing size, and we're having more of that area burned in these extreme single days events characterized by really hot temperatures and high winds. And we are the western mountains over there, where you can see that area burned really increases with aridity. And large fires really do have unique ecological events. They're not kind of just like a bunch of small fires thrown together. And one of the big unique things about larger fires is that they tend to have much larger patches of high severity fire. These larger patches are very slow to regenerate, and they're going to have legacies on our landscape for decades, if not longer. And so when we take a look, sort of a broad scale look across the region, these are results based on some remote sensing work. What I've done is looked at fires from 1985 till 2010 and used the Landsat satellite to come up with patterns of burn severity. It's basically a change in a spectral signal. It's very correlated with loss of live tree basal area. And we put them in classes based on the amount of mortality. The blue bar is less than 25%. The yellow bar is about 50 to 75. And then that red bar is really the big concern for most folks. That's the high severity part. Those are places where, greater than 75% of the more of the basal area is killed. And what we see, I just have a couple of our major vegetation types here in the Pacific Northwest highlighted. Ponderosa pine, about 25% burns at high severity. I'm just kind of curious, who would have thought that it was more or less than that? Does anybody? More? Okay, yeah, it's interesting. Some of those big patches really stick out in your mind, but it's interesting. Actually, 75% of the area out there could be having some positive ecological effects. That 25% though is about 3 to 5 times as much as we think there was historically. So a lot more high severity fire, 3 to 5 times as much in those dry forests. In moist forests, in our western hemlock forest, about 20% there. That's changed with the 2020 fires. The 2020 fires in themselves were about 50%. So these are potentially shifting. And then in our highest elevation, almost 50% is high severity, which is actually pretty in tune with the way we think things operated historically. A lot of those species are thin bark, they're very fire sensitive. And so when a fire happens at high elevation, historically, we know they were characterized by greater proportions of high severity fire. And so some of these things, they may be relatively consistent with the way that we think things operated historically. But there's some big differences to think about. And what I'm going to talk about now is these patches of high severity fire. So these are places where, greater than 75% of the trees have been killed. There's not a lot left. And what I have, geez, this is a tough one on the small screen, but it's a size class distribution. And so all the way to the left are small patches. 1 hectare is about a football field. And then as you go to the right, you get up to about 10,000 hectares, which is really very, very large. And this is the percent of the high severity area that falls into these different patch sizes. And so ponderosa pine, you can see that more than half of the area is burning in these patches that are greater than 100 hectares. We have very few historical analogs for patches that big, right? And so these dry forests, as we know, we're seeing greater proportions of high severity fire, and we're seeing that happen in much, much larger patches than we think happened historically. Western hemlock is pretty much in tune, actually smaller patches of high severity fire. This doesn't have the 2020 fires, which would be skewed much further right. And then subalpine forests, as we think historically, these larger patches are more characteristic. But again, these only go through 1985 to 2010, and we're starting to see shifts in these distributions. This doesn't include things like the bootleg fire. 2021 dry forest ponderosa pine, huge patches. I would say 10,000 hectare patches of very, very large, very, very, very large. Of course, the 2020 fires in the Western hemlock zone were like that as well. And so those are just a couple of examples how things are starting to shift as we get drier. Despite all this rhetoric that I'm giving you about these fires and at least in our dry forests, how uncharacteristic they are of historical fire regimes, one of the biggest departures actually these days is that we have way less fire than we did historically, which is almost hard to believe. But this is just a summary from the Eastern Cascades. This is a fellow named Dan Donato, who works up at the Washington DNR. And what they did is they ran some simulation models based on some historical attributes of the fire regime. And in each of those figures on the right, you can see a sort of a grayed out bar. And that would be what to expect under historical conditions. And so if we look all the way at the bottom, on an annual basis, you would expect somewhere between 200 and 3,000 hectares burned in dry forests of the Eastern Cascades. And you can see that there's that 1 year there where they actually exceeded it, but most years are really, really far below that. So far less fire overall. As you move up, you can look at the low severity again, really, really, really departed. So far less low severity fire than we would have had historically in terms of area. And then skip ahead to the high severity, you can see that we're actually hitting that, right? Almost on an annual basis. Historically, high severity fire is maybe 3 to 5% of the area burned in dry forests. And so we're having larger patches. So this is just a way to sort of think about how contemporary fire regimes are departed from the fire regimes that the species and the landscapes that we know are adapted to and experienced historically. And so I wanted to shift a little bit, speaking of the 2020 fires and things like that. And I think this is really important information for our crew in the Hood River to get. And these are sort of, basically, this is one of the early attempts at characterizing these dry east wind events, which is, an example of what we had in 2020. And there was this guy, Owen Kramer, I think his name was, I think he worked for the Forest Service. And what he did was he went to the Portland airport. And for years and years, they had been setting up this weather balloon and taking data on relative humidities and wind speeds and things like that. And he sort of summarized it all together. I took his data from a table and put it in a graph here. And what this graph shows is the average number of dry east wind days. So this is basically when relative humidity gets below a certain threshold, so it's really, really dry, and then those wind speeds get really, really up there. And there's a very clear, what I call window of vulnerability here, right? So that blue line, the average number of days is super, I mean, they almost don't happen up until about August 15th, when they really, really crank up in frequency. And so, on a year-to-year basis, it's kind of like tough to say when there's going to be a big year necessarily, but we're pretty confident about this window when they occur. And I'm guessing that you all know this because you live here in Hood River and experience these things on a fairly frequent basis. The other thing that I have added there are some of the really big historical fires that have happened west of the Cascades. And they all corresponded with these really, really big wind events. And so we've had one in 2020, but we hadn't really experienced one since the Tillamook fires in the Coast Range in the 30s, 40s, and 50s. The Yackle burn, the Columbia burn was like days off from the anniversary of those 2020 fires. A lot of that area burned again in 2020. So although fires on the west side may be infrequent, they are characteristic and they have the potential to be quite severe when these wind events pop up. And this is just a map showing hotspots of where those dry wind days are more common across Oregon and Washington. And certainly you can see there up around Mount Hood, this is a hotspot. Here up north into the Gifford Pinchot is a hotspot down in southwestern Oregon. There's some hotspots there. But these happen every year. And they are a major vulnerability to fire in this region, especially in a place like this. These are just another map of, this is, I think, the duration. So how long that east wind event lasted in 2020. And you can see in those red areas, more than 60 hours. That's more than 2 days. That's a long time for those hot, dry winds to blow, and it can really, really spread fire fast. I have the big four circled there, the ones that really, really blew up. And then there's the White River fire here that apparently was controlled before that wind event kicked up on Labor Day. And so you can just imagine what might have happened with an ignition like that White River fire had it not been put out in time for that wind event. And so we're going to switch gears just a little bit here. And we're going to sort of talk about the extremes in terms of fire effects. And a term that's become very, very popular is this fire refugia. And these are places that are either unburned in a fire, within a fire perimeter, they experience very, very low tree mortality or unburned. So very, very, very low severity, sort of that blue bar, the lower end of that blue bar, if you will. And what we have here are predictive maps of where in this Mount Hood landscape we would expect to see fire refugia under different fire weather conditions. And so we go from all the way on the left from the mildest of burning conditions to on the right to the more extreme. And the blues are associated with higher probabilities of fire refugia or really, really low severity fire effects. And so you can see that much of this landscape under really, really mild fire weather may actually have very, very low fire severity effects, maybe ecological beneficial. As soon as you ramp that up to moderate, you lose a lot of potential for that fire refugia here in these dry forests. There's almost very little left. You can see some on some north-facing aspects. There's more on the west side of Hood. And then finally, under the most extreme burning conditions, there's really very little probability of fire refugia when it's hot, dry, and those winds kick up. So there are different weather scenarios and different ecological outcomes. The flip side of that coin is high severity fire. Again, patches of fire where most of the trees are killed. And again, we have the same fire weather scenarios, moderate or mild, moderate, and extreme going all the way to the right. And so on the left, you can see that the probability of high severity fire under those mild fire weather conditions is actually pretty low, right? And so you need a little bit of weather, you need things to be hot and dry for it to get up into the high severity category. And really in this situation, according to these models, it looks like it's really the extreme conditions where we have actually very, very widespread probability of high severity fire. And so if you remember that slide I showed you where we've sort of transitioned to these fires that are now burning in larger single day events that are associated with weather, these are the sorts of effects that you would expect to see under those. So interestingly, and I as I was putting these slides together, I sort of had this question in my head that those two, when you looked at them, they sort of showed the same thing. So what I want to show you is this moderate fire weather scenario where the probability of fire refugia is pretty low. and then the probability of high severity fire is actually pretty low. And so the way that I interpret that is that under these moderate fire weather conditions, there's actually pretty good potential for what I would call moderate severity fire, or fire that kills a lot of the smaller trees in the understory, leaves the overstory, potentially ecologically beneficial in terms of restoring some structure and composition. So there's the potential for that under these moderate fire weather. And so finally, we're going to shift to post-fire resilience. And when I talk about resilience here, really, I'm talking more specifically about seedling regeneration and how quickly canopies recover after fire. And in general, from moist forests, we've seen really, really high resilience to fires, even high severity fires. This is a picture of the Warner Creek fire down by Eugene, 30 years post-fire, impenetrable Douglas fir regeneration. You can see a map of canopy cover change over that 30-year period. From 1 year, the yellows would be open high severity patches where there wasn't a lot of canopy cover. But by 30 years, it's pretty much all recovered to 40% or greater than 60%. So really, really quick regeneration, rapid response. The most abundant in diverse regeneration we see is at moderate severity. And in older stands with taller canopies and more fire-resistant trees. I'll be honest with you, I don't know how things like the 2020 fires are going to fall into this, and we're still learning about those, and so that's an uncertainty, is how things might be changing over time, especially with larger fires like that. Some of the other considerations are invasive plant species. For sure, things like Scotch broom that are pyrogenic. So those are some of the issues to think about in moist forests. Cold forests, there's a little bit less research out there. And resilience has been generally kind of variable, especially among species in high elevation forests. And so things like lodgepole pine up high that have serotinous cones, very, very resilient. They come back very, very quickly. Other species like mountain hemlock are quite fire sensitive. They don't have these aerial seed banks. They need to disperse in from much longer distances. And so resilience is quite a bit lower there. You can expect longer periods of establishment. It might take a couple decades for seedlings to establish, and it might take a century. These are slow growing, energy limited systems. It takes a while for trees to grow, so regeneration is a little bit slower. And one of the things here is reburns up on Mount Adams. Some of Sebastian's Busby work has showed that reburns are a particular way that can catalyze some of these changes after high severity fire, where your seed sources are consumed in the first fire. Things might regenerate, but they don't necessarily reach a fire resistant size by the time that second fire comes around. And then dry forests. So these would be our forests on the east side, ponderosa pine dominated forest, mixed conifer forests. And generally speaking, the research out there has found that these dry forests are fairly resilient even to high severity fire, given that there's an adequate seed source around, right? So that there's a couple trees where seeds can disperse and regenerate. There's interesting relationships with shrubs. Right, early on, shrubs can compete with tree seedlings for water, but later on, they can sort of mitigate some of the stress associated with intense conditions with no canopy cover and provide a little bit of shade. What we're finding, and I'm going to get into this a little bit more, is much lower resilience in large, high severity patches, again, where there's not a lot of seed source available, in places at the trailing edge of dry forests. And so these would be places where ponderosa pine transitions into juniper or sage or shrublands, where it's really, really hot and dry. That lower elevation limit is particularly susceptible to these regeneration failures and potentially transitions to, albeit meadows or shrubs or things like that. And there's evidence from the rest of the Western United States that dry forest resilience has declined over time as conditions have gotten hotter and drier. Reburns are certainly a threat, and invasive annual grasses, certainly cheatgrass would be a good example of that, where things can come in, compete with tree seedlings, and potentially alter the fire regime and make it more prone to burning in the future. And so here I just have a couple of maps, some work we're doing looking at probability of seedling regeneration. This is the Sheldon Ridge fire. This is just to the east of here, sort of a transition. I think these are mostly on private land, but it really is that lower trailing edge. And what you can see is the reds are low probabilities of conifer seedling regeneration. The blues are higher probabilities. That Sheldon Ridge fire is about 20 years post-fire. The Government Flats is about 10 years post-fire, but you can really see that transition from the red and the low probabilities as you go up in elevation into those higher elevation mixed conifer forests there. That Government Flats fire, there's one patch all the way to the left. It's relatively low probability. That was a big high severity patch. I actually tried to get out there today, but was unsuccessful, so I don't have any field reports. But something to think about. And then let's see, this is another way of looking at resilience to high severity fire, and I think these are probably tough for y'all to see. But we have on the far left our driest ponderosa pine, and then mixed conifer in the middle, and then our western hemlock Douglas fir sort of moist forest. And on the x-axis is time since fire. So all the way to the left is 0 to 5 years, all the way to the right is greater than 20 years. And across all those vegetation types, you can see that those blue, those higher probabilities of seedling regeneration increase with time since fire, right? It takes a little while and you start getting seedlings to come back. But what you can see is that these moisture forests, certainly that western hemlock, after 20 years, there's very, very little of that low probability of seedling regeneration. Our moist forests are really, really resilient, and we see really very limited potential for shifts to non-forest. Whereas our dry forests, our ponderosa pine there, about 25% of the high severity area out there is potentially subject to conifer regeneration failure, right? Places where there were trees, ponderosa pine, that are now not coming back. It's quite big. 25% may not sound like a huge percent, but acres really start adding up with more and more area burned. This is another figure, those same 3 vegetation zones, but it's comparing 2 different time periods. The first is an early time period, so basically prior to 2000. And then the lower in the red is post 2000. And the thing to look at here, you can certainly see the ponderosa pine. You can see that most of that shaded area is all the way to the left, right? Lower probabilities of seedling regeneration. And up top there, in the red, there's sort of an increased probability or an increased area of low probability out there. So ponderosa pine is already pretty susceptible to low probability of conifer regeneration. The mixed conifer is a little more drastic in terms of that decline, where you can see there's much more area in that later period that's skewed to the left. And then finally, our western hemlock, there's sort of that little strip, that decline in resilience. It's really quite minor, but there's still a little bit of a signal there. And so just thinking about these landscape transformations, particularly in that ponderosa pine zone, this is 22 years post-fire. This is over in the Eastern Cascades. And I just have, again, one of those patch size distributions of these places that aren't coming back. And so patches, hundreds of hectares that are being potentially transformed from forest to these non-forest types. And it's particularly strong at this trailing edge, this lower elevation. And then finally, starting to think about climate change and where things might go into the future. These are projections for 2 different scenarios, a less extreme with mitigation, and then sort of the more extreme business as usual on the right, the 8.5. And the point here is that they consistently project increased temperature, right? I think everybody knows this. Up to, let's see, under the best case scenario, 3 degrees by 2050. If you remember, we warned about 1.5 degrees since the early 1900s. So 3 degrees is frankly huge. Under those more extreme scenarios, it's greater. And by the 2080s, potentially up to 6 degrees. When we think about precipitation on an annual basis, precipitation is far more variable and uncertain, but when we look at just the summer precipitation, again, we can see declines across all those. And so, yeah, we can expect hotter, drier summers. I don't think this is necessarily news to anyone. And hotter, drier summers really translate to more fire, right? So this is a table. You don't need to look at the details. It's a little bit for, well, maybe not shock and awe, that might be overdoing it, but there's a number of studies out there that take different approaches to modeling the future probability of fire or fire size or area burned. And the point that I want you to take home here is that they all project increases in future fire. There are not climate scenarios where we see less fire into the future in our region. This is another map looking at fire suitability. Into the future. This is a statistical model, so it's based on relationships with the climate, based on fires between 1985 and 2000, and how that suitability might change into the future. So certainly our drier forests are looking to experience more change. And then finally on the west side here, these are some more recent projections and let's see, the Oregon Western Cascades are really projected to see a lot of fire increase in the future. That the Willamette National Forest there and the Mount Hood have already seen a fair bit of fire, and it's hard to think of even more into the future, but models are really consistently projecting that. So I think I'm going to hand it back to Andrew here.
Okay. Yeah, on that right note. Thanks, Matt. Matt has been provided an incredible amount of intellectual leadership in advancing this research at the regional scale, and really appreciate the summary of results that he's shared. It's an impressive body of work. Matt and his colleagues have been working on that for a long time. I'm going to zoom in and talk a little bit more specifically about Hood River County and also some of the work that we've done locally and some of the outcomes that we're seeing from fires, and end maybe hopefully on a more positive note about what we can do. Similar to what Matt showed at the regional scale, this is some research that was done in 2018, projecting future climate scenarios. And again, just to reiterate Matt's point, right? Increased summer temperatures are going to lead to more days when forests are available to burn. Similarly, precipitation projections, as you heard in the previous talks in this series on the glaciers on Mount Hood, that lowest bar on the figure on the far right is glacial melt, which essentially goes almost to zero by 2100. Both projections are showing both decreases in snow melt and in rainfall in the July to September period as well. Increased soil moisture deficit is a problem for our forests because trees need water, and drought stress is often a precursor to other issues that we see in the forest, primarily insect outbreaks and diseases. So, if you've lived here for any amount of time, you're obviously familiar with the level of kind of exposure to fire that we have here. But I think it's important to try to understand how Hood River County fits relative to other places in the U.S. West. In 2022, the Forest Service released a national strategic plan called Wildfire Crisis Strategy. This included an analysis of where federal forests in particular are likely to transmit fire into communities, or where fire from federal lands could affect things like drinking water source areas, critical habitat, electrical grid infrastructure. Hood River County in the Gorge region is one of the highest risk fire sheds in the Western United States. And as a result of this, we've subsequently been identified as a national priority landscape, one of 21 priorities areas in the country. After the designation, we were lucky to receive almost $10 million in increased federal funding for the Forest Service, primarily in some of our other land management agencies. We conducted a strategic planning process called this is the Mount Hood All Land Strategic Plan that we just recently released, covering a 3-county area: Clackamas, Hood River, and Wasco counties. Really focused on the actions that we can take to build more resilience into the system, and also to prepare our communities and create more fire adapted communities. This is kind of, so I showed you the map of the US West. This is a more focused analysis, basically looking at a sub-watershed scale in the upper left-hand part of the screen. Basically the same analysis, but just basically shown at a different scale. As you can see, the Mount Hood is kind of in the center there. Basically, it's the east side of Hood River Valley and towards the Dallas watershed, and south is the watersheds that are really identified at the highest risk. The other map on this image is showing the location where we've been planning fuels reduction and forest restoration projects and have identified other priority areas to do that work. In the Hood River Valley, we've completed the planning of the Waukoma Restoration Project. It's a really exciting project that we planned with Warm Springs Tribe, focused on actually huckleberry enhancement as well as fuels reduction. Waukoma Ridge is a place that historically was burned actually by the tribe to create huckleberry fields, and we're working on trying to create some more openings and restore huckleberry fields in that area. There's also been a lot of work. If you've gone up towards Red Hill, there's been a number of phases of forest restoration projects in that area. And then more recently, we've planned projects, and you'll see some implementation work happening up around Cooper Spur, as well as the Gibson Prairie area. So really excited about the progress that's being made there. In order to better understand the role that fire historically played here in Hood River, we have partnered with the OSU College of Forestry. Some of Matt's colleagues, actually, Dr. Andrew Marshall is the PI for the project, to use tree ring data to better understand how often low and moderate severity fire was occurring on the landscape. The first phase of this research has been completed. The map on the left shows the 18 study sites where we collected this data. They're approximately 5 miles apart as the crow flies, and at each site we're basically finding short snags or stumps, taking a cross section of the tree. OSU graduate students get to polish it and sand it, and then it goes through a tree ring machine, basically a reader that can precisely date the year of every fire that occurred on that stump. What we found is that across the East Zone, we have a pretty reliable fire record going back to the late 1600s, essentially. And between the late 1600s and late 1800s, there was a lot of fire happening on this landscape, both natural ignitions as well as indigenous burning, that would have really changed the character of what our forests look like, both in terms of the species that were present. We would have had a lot more Oregon white oak, ponderosa pine, Douglas fir, western larch, species that are generally pretty fire tolerant. And we would have had a lot more open kind of condition with large kind of well-spaced trees. You can see that in approximately 1900, fire basically turns off in the ecosystem. So as Matt had described, right, we got pretty good at putting out fires during that period. We also, because of the introduction of Western diseases and the forced removal of indigenous people, indigenous burning was no longer happening on the landscape. Matt was looking over the fire history record, and he's like, "You got to share this. This is fascinating." So, I think Matt's takeaway when he looked at the data was that we were, in many cases, in kind of pre-Euro-American settlement in the east side of Hood here, experiencing many years where large areas were burning. So the estimates that Dr. Marshall came up with were that, basically every other year we had a fire the size of Eagle Creek burning on the east side of Mount Hood. So, 30 to 50,000 acre fire occurring every other year on the east side of Mount Hood for this period of time. So an incredible amount of fire on the landscape, but predominantly low and mixed severity fire that would have been doing good fuels reduction and restoration type work. A lot of the overstory trees would have been surviving those fires. And we know that because they recorded the trees, recorded the fire, and then they kept growing and recorded the next fire, right? One of the other lines of evidence that we use to better understand the history of fire here in Hood River is the Osborne panoramas and General Land Office survey records. So this is a photo taken from Tom, Dick, and Harry Mountain, kind of on the other side of Mount Hood over by Zigzag, but there's many of these actually around other parts of Mount Hood. This is just a particularly helpful example to think about the role of high severity fire in the ecosystem. So obviously if a fire burns at high severity and kills the tree, it doesn't leave a record on the tree ring to help us understand what was going on. And so I think the main takeaway from this slide is that you compare the 1933 to 2015 panorama photo. By 2015, we essentially have continuous canopy cover on the upper elevations of Mount Hood. And you can see that in most mid to upper elevation forests on Mount Hood today, we have a lot of dense forests and a lot of continuous closed canopy forests. The upper panel, right, shows areas of non-forest. There's actually snags in the foreground. There's a lot of openings. There's regenerating forests. We have this really interesting mosaic pattern of fire that had been occurring on the landscape that created an incredible amount of wildlife habitat, and really interesting wildlife habitat, but it also acted as natural fuel breaks to stop a fire. So a lightning ignited fire would burn into an old fire scar and it would lay down. It would essentially stop because there weren't fuels in that area. The General Land Office surveys were basically occurred between 1859 and 1939. This was an effort by our government to basically try to, I don't know why this is moving around, I'm sorry. Basically try to, it's telling me to hurry up. It's looking at areas of forest and trying to map the timber resource in the United States. And the pixels are basically the black outlined areas on the image on the left show where we have fire perimeters mapped between 1859 and 1939, and specifically high severity patches of non-forest. And so you can see the upper elevations similar to the Osborne panorama photo, right? There's lots of fire that was occurring in those upper elevations on Mount Hood. The image on the right is showing fires between 1984 and 2021. Not only do we not really have any fire, I mean, very, very little fire relative to historic levels shown here. The high severity patches have essentially all moved to our low elevation dry forests. So the forests that had previously really been quite fire resilient and tolerant, survived a lot of the low and mixed severity fires. Now we're seeing large patches of high severity fire, both in kind of that lower part, that's the White River fire from 2020, and that upper left part where Matt had previously pointed out where there's a kind of a high severity patch where regeneration probability is low from Government Flats fire in 2013. That's where we had a big, that corresponds to that previous slide. To zoom a little further out and look at fires around us, we are essentially have been surrounded by fire. Eagle Creek, Whiskey Creek, Microwave Tower, Tunnel 5. It's pretty much not surprising that there's a lot of these fires recently that have occurred around us. The thing I'll just mention, because I love to geek out on this stuff, but if you want to go check out some really cool cat faces in places where you can still see sign of historic fire on Mount Hood and on the Hood River Ranger District, go up to the Talawanas Tie Trail, hike Elk Meadows, catch the Talawanas Tie, and then right there's lots of really cool Douglas fir and ponderosa pine with big cat faces and fire scars on them. The Government Flats fire, I think, is an interesting example of the types of fire effects that we can avoid by doing good restoration projects. So this burned predominantly private lands, as Matt had said, but a couple thousand acres on the Mount Hood National Forest. this is basically standing on that edge. This photo was taken from essentially the edge of that high severity patch. So behind us is an untreated forest that's going to get restored as part of the Gibson Restoration Project. And in the foreground is, you know, a couple thousand acres of high severity fire that burned in 2013. In this particular case, there was a lot of old growth and mature trees that unfortunately died in that fire and are going to take a long time to you know, to recruit back onto the landscape. And we're really seeing low levels of tree regeneration in that area. MAP's model predicted that, and that's certainly what we're seeing on the ground in this case. So I started earlier talking about you know, mitigation and adaptation, and Cindy asked me to say a few words about kind of the state of the research on forest carbon. And it's a very political topic, as you might imagine, but there's been some interesting work looking at essentially carbon dioxide emissions associated with wildfires in recent years. And in these big fire years, we're essentially seeing wildfires be the largest single source or one of the top three largest sources of CO2 emissions at a statewide level. So, you know, a big fire year like 2021, 30 to 40% of our state's emissions are associated with wildfires. And this obviously is not great. It's creating this positive feedback loop where we're emitting more carbon, contributing to climate change globally, which is increasing temperatures and likelihood of drought, leading to more fires. So the efforts that we want to invest in, and you know, really where our mindset is at, I think, in terms of a collaborative partnership, is how do we stabilize carbon stores in our dry forests in large fire tolerant trees. And so there's a paper that's going to be published in the next few months by a guy named Josh Wolofsky. And what he found was that essentially the amount of live standing carbon that we have in our Pacific Northwest forest today is actually pretty similar to what was here pre-Euro-American settlement, which is an interesting finding. The difference is that the distribution of that carbon has been shifted to a lot of large trees to a lot of small and medium-sized trees, right? So we have a lot more trees on the landscape, and we also have a lot of that carbon stored in species that are not going to be particularly resilient to drought and fire. So these overly abundant dense forests can lead to these big pulses of CO2 emissions, and also lead to drought-related mortality. And so our efforts to thin out and remove some of the small and medium-sized trees to select for species that we think are going to be better adapted to hotter and drier conditions and fire is also an effort to try to stabilize those stores of carbon and standing live trees, and try to reduce the potential for big pulses of emissions. I wanted to pull back one of Matt's slides on fire refugia, because I think this is a really important concept as we think about mitigation and the role that our forests can play in mitigating the effects of climate change locally. These maps are really helpful in us targeting areas to not treat, right? So we're not going to be able, it's not possible logistically or economically to treat the entire landscape, and that's not our goal. Our goal is to try to be strategic about doing that work in places that are going to give us the best chance of adapting and preparing these forests, obviously, but also for firefighter safety, for community wildfire risk reduction, and other values that we have for forests. So these places of refugia are in some ways places that I think about where we can maintain closed canopy late seral forests that are going to be important for species like the northern spotted owl that depend on that habitat. These places are going to be harder to maintain in the future, but tools like this give us a sense for where we might start looking for them on the landscape. There's we talk about fuels treatment, and sometimes I don't know if people always understand exactly what that means. So I want to spend just a couple of slides talking about fuels treatments and some of the research on what we're finding at kind of a stand or unit scale in terms of how effective these are at changing fire behavior. At the top of the panel, you can see essentially an untreated forest condition. under, moderate fire weather. These are still often burning at high severity, and we're losing, most, if not all, of our canopy cover and live trees. We have thinning, and then we have prescribed burning, and then we have the combination of those two treatments. So thin only is somewhat effective at reducing and moderating fire behavior. We see that the increase in ladder fuels in particular and canopy cover can reduce potential for tree loss. Prescribed burning is really effective. In places where we can prescribe burn, that's going to be one of the most effective tools that we can use because it reduces surface fuels. And it reduces the severity of fire that can kill trees. And even more effective than just prescribed burning is that thinning and prescribed burning combo. And this is going to be the reality in most places for the Forest Service in particular to feel confident that they can control a fire that they start. They're typically going to want to treat the fuels first. They're going to want to thin the forest before they put fire back on the ground in those places. This is an image taken by the Natural Resources Director from the Klamath Tribes, a project that they've been working on with the Fremont-Wainema National Forest for a long time. And then in 2021, the bootleg fire happened. And so it was a really interesting opportunity to try to understand, how do these treatments actually look on the ground after a big fire. This is a 400,000 acre fire, third largest fire in Oregon history. So we see the no treatment areas on the kind of the far right side of this aerial image, burned at high severity. The thinning only prescription that was implemented on the left side of the image certainly moderated fire behavior. Some of those trees will likely survive, but that thinning prescribed burning, that combination of mechanical fuels treatments with underburning as a follow-up treatment was super effective at keeping live tree cover. These are just a few images of some of the projects that we've worked on locally through the collaborative efforts. This is a pre-treatment condition. So this is what a lot of our stands that we're working in look like. This is basically a plantation that had some replanting, but also natural regeneration in it. Lots of dense and small, medium-sized trees, essentially. This is an area up above Lawrence Lake that was treated, part of kind of Red Hill and Lava, some of the projects that we've done up there. This had a commercial thinning, so this was a thin-only project. There was some trees that were able to be sent to the local sawmills, supporting jobs and helping to offset the costs associated with some of the restoration activities. The prescription was to thin from below, so we retained all the largest trees and the more kind of fire-tolerant, drought-tolerant tree species that we could. And then you can see there's kind of multiple age classes and different cohorts of trees that are growing around it. So create a lot of diversity in this stand. This is a kind of further east. So this is actually in Wasco County off the 48 road. But this is an area that we worked with the Forest Service on for a number of years. This was mechanically thinned. It was a non-commercial thinning that they did in the stand first, and then they were actually able to successfully reintroduce fire. This was the first prescribed burn that's happened on the Mount Hood National Forest in about a decade. It was about a 220 acre prescribed fire that was implemented 2 years ago. So it's really, this work has kickstarted the reintroduction of fire into the ecosystem, helped the Mount Hood National Forest rebuild their prescribed burn program. And this is what we would consider a restored condition. So overstory dominated by, Oregon white oak, ponderosa pine. There's a few scattered fir in here, but a condition where, native bunchgrass community is reestablishing, and a condition where if fire burned in this area, we would think that there would be, continued ecological benefit. I'm going to wrap up with just kind of two slides on what we can do to be prepared as we go into wildfire season. And I think we're in for a really interesting wildfire season. And for those of you who don't read the news or pay attention to politics, you're like, God bless you. Like, I wish I could do that. I suspect none of us can do that though. So the Forest Service has been put through the ringer, and we've lost a lot of wildland firefighters. We've lost about 25% of the Forest Service staff nationwide, and a lot of people who support fire. And so our Forest Service partners are not likely to be very well prepared for this fire season. And Oregon is coming out of a historic fire season. Our firefighters that work for the Oregon Department of Forestry are still tired from last year, to be honest. And so I think the majority of wildfire starts, over 80% in Hood River County, are human caused. Just please don't start fires would be the first thing, especially during, any time basically from May to September. The most common sources of human caused fires in Hood River County, anybody know? Sparks from? Yeah, that's actually one of them. And the other one is pile burning. So if you or your neighbor are burning a pile, or if you're dragging a trailer, do your part. Please don't start fire. The other thing that kind of blows my mind is that every year the Mount Hood National Forest still responds to and puts out, at least 100 abandoned campfires every year. So please, if you are out hiking, you see somebody during the burn ban who's got a fire going, help them put it out or call it in. We didn't spend a lot of time talking about kind of evacuation and emergency preparedness. It's kind of outside the scope of this talk, but I do want to mention it just because Hood River County recently updated the Community Wildfire Protection Plan, which is a really key planning document that outlines the strategies that we're going to take to restore landscape resilience and also prepare our communities for fire. It includes a number of strategies related to emergency preparedness, and we have a really great tool actually locally, the emergency alert program. You can scan that QR code. You could go on the county's website and sign up. It's basically a way for them to notify you when there's a disaster or wildfire, any natural disaster really for that matter, in the county, and it can give you an advance notice that something's happening or you may need to be prepared to think about evacuating. As we're seeing, I'm sure you saw with the LA fires and many fires now that we have these, fires burning under extreme conditions with high winds. People aren't getting much notice to evacuate, and that could very much happen here in Hood River. And so having a go bag, having a list of things that you need in terms of medications, important documents, it's always a good idea to be prepared so you're not left on your heels scrambling in case that were ever to happen. There's a couple of really cool resources that Oregon State University helped us pull together. There's both English and Spanish language versions of Home Hardening and Defensible Space resources over by the door, as well as a booklet we put together on living with fire in Hood River. So I'd encourage you on your way out, check that stuff out. If they supplies run low, we have many more, so don't be afraid to grab some. So with that, I'm gonna maybe invite Mac back up here and see if there are any questions. Sound good?
Yep, sounds good.
In the green?
Driving really good with the dry forests and how they're converting the shrubs. And I guess I'm just wondering, is that a bad thing, or maybe we're getting more ponderosa pine on the upstream, maybe it balances out. But you say more about that?
Yeah, I mean, the next step with a map like I showed you is really to compare it to a historical photo or something like that, right? Because we've had ponderosa pine has been encroaching those places for the last century with fire exclusion. And so some of those places, yeah, where there's forest loss, they might be young trees. So that could be one situation. The other situation I've seen both are where you have big old growth trees that are lost, and there's those transitions as well. So, yeah, ecological context is important for those for sure. And I think if you talk to, a botanist who was really into sage, they would tell you that it's a good thing. There's always someone who has a different perspective on everything.
Fire resistant species or trees in our area in Hood River County.
Yeah, so ponderosa pine is certainly up there. Gets thick bark, grows really, really tall, sparse canopies, homes up high. Western larch is one of the few conifers that can actually reflush. If its ground gets scorched, it can resprout. Those would be the top two. Most trees, when they're smaller, are less fire resistant. Certainly grand fir is not very fire resistant when it's small, but it does get thicker bark when it gets larger. Douglas fir is probably one of the most fire resistant species too. Certainly thick bark. Anything can get really, really tall. I mean, it's thick bark and tall canopies. Yeah, those are the traits to look for. Compared to like your subalpine species, which have really, really thin bark.
I know it's bad to bring up social sciences around natural science people, but I'm curious, given the high percentage of campfires that are resulting in wildfires, has there been any research around the best ways to deter people from having campfires when they shouldn't?
Apparently it hasn't worked. I can't answer that question. I think did Eric take
I
that?
have an idea.
Uh-huh.
How about a song that is
Right.
So Sarah,
I was thinking more about a billboard as you come into the gorge.
that too.
Yes.
Yeah.
Yes, but I'm just thinking like don't, that, breeze down the drain. Opera. Yeah,
Right.
I think probably half of the folks in here went and saw. Like, maybe. Maybe.
Yeah, certainly Smokey the Bear had some.
Yeah. Yeah.
Yeah.
About the impact of these big fires on the watersheds, on like maybe both above ground and below ground.
I'm not sure I can speak to that real well, to be honest with you. I do know things that the hydrology can be really hard to predict depending on the amount of flow that comes from underground versus above ground. I know that on the west side, there's some folks that I talked to at Oregon State that are finding actually surprisingly little effects, long-term effect of those big 2020 fires. A lot of the vegetation comes back really quickly and can shape things. But I think it's a pretty complex issue and one that's far tougher to study than the work that I do, so.
You showed some maps of your modeling and showed kind of Goldilocks conditions for low severity fires. Is there anything that you can glean from that research that maybe contradicts typical practices for prescribed burns, or maybe give some like particular insight into how prescribed burns should be prescribed?
I mean, I think prescribed fire is tough because the appropriate window to get the desired effect is not necessarily one that people are comfortable with burning in. And it is, I mean, it's when I first did that work about all that low severity fire that we have in our dry forest, low and moderate, it's the vast majority, and those fires are burning in August, right? And so even still, but you get those hot, dry days or weak conditions and you get a bootleg fire. And so I think, yeah, prescribed fire is tough. I lived in the southeastern United States for about 10 years before I came here. And the southeastern United States, they treat more acres with prescribed fire than the rest of the western United States together. It's amazing. And it's part of it's cultural, but the other part of it is that you get dry days in the winter when there's no snow and the whole state can light off and go for it. So it's yeah, I think there's a very short window here where you can actually get a fire going and give a prescription, but
Thank you.
yeah.
The town of Paradise, California was devastated by wildfire 5 or 6 years ago. How do our local communities compare in terms of fire sustainability to Paradise, California?
Geez, if you remember that map that I showed about those dry east wind days, you guys are nothing compared to Paradise, California. It is really scary, those winds, and certainly like the Los Angeles fires, right? It's the same phenomenon there. I think it's probably hotter, drier, and windier there. In that neck of the woods.
I was curious if people did any others. On the western side, because you're doing the transfer, you're seeing the transition to open or non-forest systems on the east, or are you seeing any like deciduous changes in deciduous regeneration on the west side?
The work that we did was primarily looking at conifer regeneration, but hardwoods, they love fire, right? If you've been out in Eagle Creek, I mean, big leaf maple, right? 2 years after a fire, it's this high. They are very, very resilient to fire. Some of the places today that I was in that, is it the White River fire? You know, big conifers gone, long gone, and the white oaks sprouting right back or survived. So I think that's one of the things that we'll see. I mean, certainly things like chinkapin, I would imagine y'all have over here, and probably a much greater component of hardwoods in the future. So.
Perhaps comparing the numbers of historical fires occurring annually versus numbers of fires today, and we're way below historical averages right now, except for that high severity.
Yeah.
You can speak a little bit more to the difference of the high severity fires right now versus the historical high severity fires. Like, are those looking the same?
So they're looking very different. So what we're seeing now is a greater proportion of the area burned is high severity. I think it's about like 25%, give or take, these days, and it used to be like 3 to 5%. And then when it happens, they're in these really, really large patches that we don't really have much evidence of those. And so historically, you know, high severity fire was part of dry forests, but it happened in really, really small patches, you know, open a couple trees here and there where fuse accumulated. So it would have been a different grain to it, if that makes any sense. Lots of small patches across the landscape versus 1 or 2 big ones is what we have.
Still get that high severity, even if it's a small.
Yeah, yep. Yeah, I mean, I showed you guys a lot of figures. If you remember the size class distributions, you'd see a lot more smaller patches historically than these like 100, 500,000 hectare patches that we see today. Yeah.
A historical question. I hear that the Forest Service started putting campsites in, you know, big, huge campsites, as a way to prevent fires from being spread out over the entire forest. It kept people congregated in an area where it's easy to drive to in case of fire. So it kept people that start a lot of fires, right? We agree on that. But it kept them located in areas where you get to it very quickly to fight the fire. And also keep people in line in terms of how they manage their fires. Is there any truth in that?
I have no idea. I mean, it makes sense. I can buy it, yeah. But I don't know if there's any truth to that.
It's not, you know, not necessarily just recreation. It was started.
Some strategy there, yeah.
Well, you're no help at all.
I do know that the Hood Ranger District, the Hood River Ranger District has tried to close off a lot of those remote sort of camping sites, like you're saying, Roger. So I think there is an effort. Gary, in your time at the Forest Service, did you speak at all to that trend?
Yeah, we do close sites here and there, but I can't think of one, at least that I was involved with, that was closed specifically from the fire risk perspective. That is not happening. And I don't know, Roger, I certainly never heard, I worked in forestry for 30+ years, I never heard that, I mean, it sounds like it's a legend.
Just a quick anecdote on that, in the southwest, northern Arizona, they would actually close off entire public access to the Coconino and Kaibab National Forest during high severity fire risk. But I had a question, given we have such a patchwork of private and public ownership of land, has any big like meta-analysis been done on commercial timber operations and effect on long-term fire?
I think these days they shut things down pretty effectively. I mean, certainly in the early 20th century, all those big fires were related to logging, but I don't know that. I think it's more careless people. I think people that are out there with chainsaws. I mean, when we go out with Andrew to cut fire scars, we're done by like 10 a.m. There's laws.
I guess more on like the risk of potential fire, like that, looking at commercial logging as a treatment.
As a fuels reduction treatment?
Yeah, or just a forest management treatment.
Yeah, I mean, certainly thinning, is targeted at mitigation for fire. I think timber harvest is a pretty broad statement, but I think, there's a role of active management with prescriptions and things like that can mitigate fire effects, certainly under moderate fire weather conditions for sure, so.
The fires last summer in Eastern Oregon were huge and massive. I never got a grasp on what kind of land that was. Was it heavily forested areas? Was it private land? Was it national forest? What led to that massive?
Ooh, cheatgrass. Could be cheatgrass, could be a lot of things. Yeah, I mean, I think there's a lot of interspersed grasslands and woodlands and savannas and things like that up there. But I haven't taken a close look at that fire yet, but one of the fire history studies that Andrew did was down in the Fremont Wainema, the area where that the bootleg fire was in 21. And if you've been down there, it's pretty flat, right? With the occasional cinder cone. And I mean, there were 40 to 80,000 acre fires every decade, where you have continuous dry fuels and not a lot of barriers to spread. Fires can get pretty big. And more topographically complex landscapes like the fire history work we're doing in the west side, most of the fires were actually pretty small. Plots that are separated by a couple kilometers very rarely share the same fire dates. Whereas in the figure that Andrew Spaeth showed, it was pretty common for plots that were 5 miles away, 5 or 6 of them to share the same fire date. So things like topography and fuels can have a big effect on that and how big fires get. And